Hello guys, welcome to the CSS channel. Today we are going to name aromatic compounds. A. Monosubstituted benzenes, systematically named in same manner as other hydrocarbons. Benzene used as a parent name, and we have here three examples. And in these three examples, benzene is the parent chain. Benzene is the parent chain, and here also benzene is the parent chain. And here bromine is a substituent. NO2 is a substituent, and propane here is a substituent. Now, when we are naming aromatic compounds, if we have one substituent where the carbon chain is not more than 7, then we name benzene as the parent chain. For example, here benzene will be the parent chain, benzene will be the parent chain, and here also benzene will be the parent chain. But here we have 3 carbon. For example, if we have like 6 carbon or 7 carbon, probably 7 carbons, then hexene will be the parent chain and benzene will be the substituent. But in this case, the number of carbon is less than 7, so benzene will be the parent chain. And now let's see how to draw these compounds. Now here, these are the substituents. These are the substituents. And this is the parent chain here, which is benzene. This is the parent chain, and this is the parent chain. So it's very easy to name aromatic compound such as these ones. You first draw the benzene as a parent chain, and then you attach the substituents into the benzene. For example, here we have only one substituent, so you can attach the substituents at any part of this benzene. Here also we have only one substituent, so you can attach the NO2 anywhere. Likewise here also. B. Disubstituted benzene, that is benzene that has more than one substituent. Now we have here a few prefixes. One, we have auto. Auto disubstituted benzene has 2 substituents in a 1-2 relationship. For example, here, this chlorine substituent and this chlorine substituent, they are related in 1-2. They are in 1-2 relationship. They are in 1-2 relationship. So in this case, it is auto. And we can name this as auto dichlorobenzene. Auto dichlorobenzene. Okay, but we can also name it as 1, 2 dichlorobenzene. It's all the same. You can either choose 1, 2 dichlorobenzene or you say auto dichlorobenzene. Now the second one also we have meta. Meta substituted benzenes as its substituents in a 1,3 relationship. For example, here we have two substituents, that is methane and methane. And these two substituents, they are in 1,3 relationship, so they are meta. All right. So here we can call this compound as meta dimethyl benzene. Meta dimethyl benzene. So here we have, because there are two methyl substituents, so we use di. Likewise, here also we can name this compound as, we can say 1, 3 dimethyl benzene. It's all the same. You can either choose 1, 3 dimethyl benzene or we say meta dimethyl benzene. But when naming aromatic compounds, we prefer to use these substituents, for example meta, than 1, 3. Now the third one we have para. Para disubstituted benzenes as its substituents in a 1,4 relationship. For example here, this substituent and these substituents, they are in 1,4 relationship, hence they are para. Again, we can also name this compound as 1, 4. We can also call this compound as 1,4-chlorobenzene aldehyde. It's all the same, or you can say para chlorobenzene aldehyde. It's all the same. Now, aromatic substances have acquired non-systematic names, that is common names. Common name for methyl benzene is toluene or toluene, whatever you call it. Common name for hydrobenzene is called phenol. And common name for aminobenzene is aniline or aniline. Now here, if a benzene with a methyl substituent attached to it is called toluene. A benzene with hydroxyl group, that is OH, attached to it is called phenol. A benzene with NH2 group attached to it is called aniline. A benzene with a methyl group, that is bonding to carbon and double bond of oxygen, you can call it acetophenol. A methyl that is bonded to salt. A benzene that has a substituent of CHO, we call it benzaldehyde, and so on. Now here, it is very crucial to memorize these common names, because They will be very useful in the future. um, they will be very useful when we start naming aromatic compounds in our future videos. Now let's have a quick summary about auto, meta, and para. Now let's consider these substituents. Methane. Now it is very clear that methane and these substituents here, their relationship is 1:2. So if two substituents has a relationship of 1:2, they are meta. Sorry, excuse me. They are auto. If two substituents um, have a relationship of 1:2, we call it auto. And if two substituents are in 1:3 relationship, we call it meta. If two substituents that are in 1:4 relationship, we call it para. This is a quick summary of auto, meta, and para. Thank you for watching. Please subscribe, like, and share our video. See you in the next video. Thank you.